So in this problem, we need to verify the following. So we'll begin our problem from the left-hand side. Now clearly on the left-hand side, in the numerator, we have the product of two cosine function. So we have cosine of angle 8a times cosine of angle 5a minus, then we also have the product of two cosine function, cosine of 12a times cosine of angle 9a, fine, divided by the denominator part has two terms. The first term is the product of two function, sine 8a times cosine of 5a, added to cosine of angle 12a times sine of angle 9a. Now what we have here is the product of two trig functions. Yeah, if we consider the first term. Now what we'll have to do, we'll have to use a transformation formula to convert the product to a sum. So let's state the transformation formula that we will be using here. So here we have the four transformation formula. So if we have the product of sine A and cosine B, it transforms as a sum of two sine function. If we have the product of cosine A and sine B, it transforms as a difference of two sine functions. Similarly, we have the product of two cosine function transforming as a sum of two cosine function, and the product of two sine function transforming as a difference of two cosine functions. So accordingly, we'll apply these transformation formula. However, you can notice here that the factor 2 is missing in each of the case. Now that's not a big problem. All we have to do is divide both numerator and the denominator by 2. So we have 2 times cosine of 8a times cosine of 5a minus 2 times cosine of 12a times cosine of 9a. Then in the denominator, we have 2 times sine 8a times cosine of 5a plus 2 times cosine of 12a times sine of 9a. So this will be equals to, now for the first one, we have cosine of 8a times cosine of 5a. So that means we have the product of two cosine function. This will transform as a sum of two cosine function. So we'll have cosine of angle 8a plus 5a, so that's going to be 13a, plus cosine of angle, the difference of 8a and 5a, so this will be simply 3a. Fine. Coming to the next one, so we have product of two cosine function. Again, it will transform as cosine of 12a plus 9a, so that's going to be 21a, plus cosine of angle, so the difference is going to be 3a, whole divided by, now we have 2 times sine 8a times cosine 5a. Clearly 8a is greater than 5a, but assuming a is positive in nature, then we will have to use this particular transformation, which will transform into the sum of two sine function. So we should get sine of angle a plus b, so 8a plus 5a will be 13a, plus sine of angle a minus b, so 8a minus 5a will be 3a, plus we have 2 times cosine of 12a times sine of 9a. So here we can clearly observe 12a is going to be greater than 9a. So we'll use the second transformation formula. So we have sine of angle a plus b. So 12a plus 9a is going to be 21a. We'll have to use the difference of sine function. So we have negative sine of 12a minus 9a. So that's 3a. Now, further simplification gives us cosine of 13a minus cosine of 21a in the numerator. Here cosine of 3a gets cancelled, divided by, in the denominator we have sine of 13a plus sine of angle 21a. Now what we have, the problem has now reduced to the difference of two cosine functions in the numerator and the sum of two sine functions in the denominator. Now we'll have to use the other transformation formula, where we go from the difference or sum of trig functions to their corresponding product. So let's specify those formulas as well. So here we have the sum of sine, difference of sine, sum of cosine and difference of cosine. So they're accordingly getting transformed as a product of the respective trig function. So for the numerator part, we have the difference of cosine function. So we're going to apply the transformation formula cosine alpha minus cosine beta. So let's apply that. So here let's treat 13a to be alpha and 21a to be beta. So we should get negative 2 times sine of angle. So we need alpha plus beta. So that's 13a plus 21a. So that's going to be 34a over 2. Multiplied to sine of angle. So we need alpha minus beta. So 13a minus 21a. So that's going to be a negative 8a divided by 2. Whole divided by, so we have now the sum of two sine functions. So we're going to use this transformation formula. So we get 2 times sine of angle. So we'll treat 13a as alpha and 21a as beta. We'll have 13a plus 21a. So that's going to be 34a over multiplied to cosine of angle. So we have the difference of the angle. So that's going to be negative 8a over 2. Fine. So let's further simplify. So we have negative 2 times sine of angle. So 34a over 2, that's going to be 17a. Multiplied to sine of angle. It will be sine of, let's do it here, sine of angle. Negative 80 over 2 is going to be negative 4a. But we know that sine is an odd function. So that means this is going to be equals to negative sine of 4a. So since we get negative sine of 4a and we already have a negative sign here, so this is going to be positive sine 4a. Divided by, we have 2 times sine of angle 17a multiplied to cosine of angle. Now here we have cosine of negative 4a. Cosine is an even function. So that means we are going to get positive cosine of 4a. So we are only left with positive cosine of 4a. So 2 times sine 17a will get factored out from the numerator and the denominator. We are only left with the ratio sine 4a over cosine 4a, which is nothing but the tangent function. So we are left with tangent of 4a, and this is the expression on the right hand side. Therefore, we have successfully showed that the left hand side of our given expression, so this is exactly equals to the right hand side, which is tangent of 4a.